Hi, and welcome to the OCP demo showcase of the Distributed Disaggregated Chassis, or DDC for short. My name is Inbar Lasarab, CMO of DriveNets, and I will be your host for this session. DriveNets worked with an ecosystem of partners to open the traditional router model and create DDC. UfiSpace and Credo are two of these partners, and they are participating in the demo today. This demo includes a shorter version of the full demo to give you a taste of its key elements. So let's get started. So what is a distributed router? It is a new model which literally disaggregates the traditional chassis into its building blocks so they can scale. First, it starts with disaggregating the hardware and the software. The cloud-native software is from DriveNets, and the hardware is based on standard networking white boxes. Second, it disaggregates the control plane from the data plane. The data plane is based on two white box building blocks, NCP and NCF. A single NCP is a 4 terabit per second router, while clustering NCPs and NCFs together create any size router up to 768 terabits per second. This creates a very flexible router model. And third is the cloud-native software, based on containers that are distributed across the white boxes, creating a single router entity. The demo you're about to see is based on a collaboration of 3 companies: UfiSpace, which supplied the white boxes to build a large router cluster of 96 terabits per second with 7 NCFs and 24 NCPs. Second, Credo, which supplied the 400 gig AEC cables to connect the white boxes. And third, DriveNets, which provides the network cloud software. So now, let's talk about the software.
So the software that powers this demonstration behind me is the DriveNets Network Cloud. It creates operational simplicity out of hardware complexity. The DriveNets Network Cloud consists of the DriveNets Network Operating System, or DNOS, and the DriveNets Network Orchestrator, or DNOR. It is a clean sheet design system of software that's built to support all the way from a single box through the 96 terabit version behind me, as well as systems up to 192 terabits. It's distributed software based on containers and microservices and allows scale as you add hardware elements to the system. Most importantly, it creates operational simplicity for both the network as well as the operator by making this collection of hardware behind me look like a single network element, a single router in your network.
Now that you understand all the elements of the distributed routers, let's see how they all come together into a single router cluster with DNOR, DriveNets Orchestrator, which manages the router as a single system working as a virtual chassis.
This is DNOR, the DriveNets orchestration system. From DNOR, you have the ability to manage all of the clusters configured in your network. From this dashboard screen, you can see the total capacity of the network, the capacity of each individual cluster, and other interesting statistics like the total network utilization. The operational view shows the events and health of all clusters in the network. When we use DNOR to drill down into a single cluster, we can see information about that cluster, including uptime, configured size, in this case 192 terabits per second, and version information. In the lower left, we have hardware status information, including that of all of the individual white boxes in the network element and the port status. On the lower right-hand side, we have information about the DriveNets software, including the containers and processes that are running on this particular system. Using DNOR, we can even drill down into the status and health of an individual white box in the system. Using the DriveNets Network Operating System, DNOS, command line interface, we can run a show system command and see all the information about this cluster. We can see its type and size, in this case 192 terabits per second. We can take a look at versions of software installed on the cluster, and we could take a look at the list of individual elements which make up this cluster, the NCCs, controllers, the NCFs, or the fabric elements, and also the forwarding elements, the NCPs. From this single interface, you can see every single component inside of this cluster. Another interesting command is the show system backplane command. Using this command, we can display, monitor, and verify all of the individual connectivity between the white boxes in the system. From the DNOS CLI, you can also configure routing protocols. Even though there might be hundreds of individual white boxes in this cluster, everything from routing protocols, interfaces, and services are configured through a single CLI interface like a traditional router.
The distributed disaggregated router model architects the network in the same way hyperscalers have architected the cloud, software-based, running over white boxes. With the constant need to scale network capacity and lower network cost, the DDC model pretty much makes the traditional router chassis a thing of the past. Thank you for joining us today.